So with our diameters and lengths roughed and finished and our groove machined, we'll move on and do the screw thread next. So to do that, we push S on the keyboard to bring up our search box, and then we're going to type in turning again. So again, if we type in turning into this box, it brings up all of our turning operations that we need for cam. And it's not that many, so we're going to be working through all these anyway. So our next thing we need to do is look at turning thread. So we're going to click on this. Again, as usual, we need to start off by selecting a tool. So I'm going to look for a thread tool. So it would be turning threading. And then select all on our library. And it's given us the massive option of just 3. So we have our thread tool here, plus OD and these two different kinds of turning tools. So I'm just going to use our standard thread, our ISO triple up here. And I'm going to click on OK to put that tool into our machine. And don't forget to select the correct tip to match the thread. So OK, so that's in there. We're not using a towel stock, flood coolant, outside threading, that's fine. I'm going to use constant surface cutting speed for my thread. Maximum spindle speed, let's say 3000 RPM. We don't want to drive our spindle into oblivion by going too fast. Okay, so that is our first tooling section set up. Now we're going to go over to geometry. So it's asking what our face threads are, and I'm sure it should be able to work it out because we can see it in our model, but I'm going to select this anyway. I don't know whether we need to select the bottom or the top or all of it. Let's try the bottom. There we go. And it's put in our thread path there. So we're going to come in there with a bit of lead, and then we're going to cut the thread, and it's going to stop exactly there. Well, I want to go a little bit past the end, so we've got a nice little run out, and that's why we've got this groove here anyway. So we might as well use it. So when it's got confinements here, our front side stock offset, 1/4 inch, 6.35 millimeters. Why does it do this? Well, when we're doing any kind of thread work, whether it's on a manual lathe or CNC, although CNC machines have the recurring screw lead ball, the recurring screw thread lead screw, it still can get a little bit inaccurate if we come straight in on the face and go across. It's nice to give the machine a little bit of a lead in, just so all the gearings can lock into place and the spindle RPM and the travel of the turret locks in, so they're moving at the same speed. So if we give it 1/4 inch or 6.35 millimeters running, it makes all this a little bit more accurate, and it stops any problems that we may have from the machine, especially if we're using older CNC machines. Now our backside offset is this area here. At the moment it's stopping exactly at the end of the thread. Well, I want to bring this back a couple of millimeters. Oops, got to plus it up a couple of millimeters, sorry. Now, because our slot is 2.5 millimeters, if we plus up 2 millimeters, it will stop 0.5 millimeter before that face there, so it doesn't crash. So that's fine. I'm going to leave that at 2 millimeters. And then we move along to our next option, which is our clearance. So that's all fine. I'm going to leave that alone as we normally do. So now we're going to go across to passes. Now passes, we need to give it a bit more information about the thread. It's saying here our thread depth is 1 millimeter. It's actually 1.667. I'm going to change this right now. And so that's the depth of the top of the tooth to the bottom of the tooth, both sides. So our number of step downs 5. Let's increase that a little bit to 8. And our thread pitch is 2.5 because we're using a 20 millimeter by 2.5 M20 coarse thread. We do multiple threads. This is multiple starts, so we can have a 2-start or a 3/4 start thread if need be. In feed mode is constant in feed. I tend to just leave this as constant in feed. That's fine. Fade thread end. Now we don't need this because we're not going to be coming away from this because we've got this little recess here, so I can turn that off. I always like to do a spring pass with threads. It makes them a lot more easier to obtain the dimensional accuracy that I require. So with all that in place, we now go across to our link in, and again, that's fine. So I'm going to click on OK, run the simulator, and see if this works. It's interfering with that wall there. If we go over and have a closer inspection like this. So I'm going to bring that in a little bit because we don't need it that close. As long as it clears the end of this thread, that'd be fine because we're not screw cutting along here. So it doesn't like that. It's getting a little bit close. I mean, it's not causing up any errors, but I don't like that. So I'm going to change that a little bit. Apart from that, that looks fine and perfect. So I'm going to stop our simulation by clicking close. Let's go back in and make an edit on that. We would open up our box under thread here and double click on this option here. And that brings us back up to our dialog box. Now under geometry we have our backside stock offset. So I'm going to reduce this down to 1mm to bring that a millimeter away from the edge, and we're still more than a millimeter away from the end of our screw thread. So let's run this through the simulator and see how this looks. So tool's coming in, screwing up, and it's still turning red, but it's still got lots of clearance away from there. And we have no warning on our tool here. So that's fine. I know that's not going to collide. That looks great to me. So we're going to go with that. Okay, so I'm going to close our simulator. And then we can move on to our next tool. So our next tool now would be need to center drill this hole. So let me orientate my part so we can see it nicely. For that we need a drilling operation. We can click on this icon here, or we can push S on the shortcut key and type in drilling. And there's the same operation here as it is up there. So under tooling, we're going to need a center drill or a spot drill for this. So I'm going to go with a center drill. So we go up to all, select our operation. I'm not seeing drilling here, but we can go up to our type up here and select center drill from our type and then click on OK. And this gives us all our different center drills that we have available to us. Then we just select one that we happen to have. If not, we can make one up as I showed just now. So I'm going to go with the 1/4 inch center drill. We've got a 10mm hole. Even if we go full depth, that still gives us 4mm under size. So I'm going to go with the 1/4 inch one and click on OK. Now it's aligned us up right. It knows that we're doing Z-axis work, so that's put us there. So we got our speeds and feeds that we can adjust to match our tool. Under geometry, it's asking us for our hole face, and it's highlighted in blue, which means we can select that now. So I'm going to click on this here to select our hole face. Now we don't want our center drill going right the way through because I'm sure the turret will collide with the end of the part at some point during that. So we do need to bring down our back distance of how deep we're going with this. And we do that in a minute. So the rest of these we don't have to worry about too much for this. Same diameter, so if we had a bunch of holes we would click that and it would write a program to do all the holes. Not normally used on lathes, especially with centerline work. Order by depth, again we've only got one hole so we don't need to worry about any of this, and we're moving over to our heights. Now this is the interesting part when it comes to center drills, because if we don't change all this, our center drill will try and drill the entire depth of the hole, and we don't want that. We only want it to drill in a few millimeters just to give us a spot at the end. So these are our clearance planes here, but the bottom height is the one we use to control the depth of our drill. So at the moment it's hole bottom. Now we can change that to anything we like, hole top, stock top, clearance height. What I'm looking for here is model. So we want model top, which will take that plane right to our front face here, this blue line here. So if we kept that at the moment, it wouldn't drill a hole, it would just take the tool, just touch on the front of the material and go home. So using our offset here, we can make this a little bit deeper. So if we set this to 4mm, and another great thing I like with Fusion here, it's showing us our angle of our center drill here. Look, so we know if we go in a little bit deeper, for example, something like that, and we know it's too deep because it's showing the main diameter of the center drill. So we can adjust our offset here to make sure that it does lead in with an angle, our 60-degree angle here from the center drill, but it doesn't go so big that the rest of the center drill follows in, leaving a step. And we can do all that visually in Fusion. So we know 5mm deep with our 1/4 inch spot drill, our 1/4 inch center drill, will leave us with the correct angle. Okay, so these two are clearance planes. It was rapid to that, feed to that, drill to that, and then go home. And cycle, this gives us the option to decide which drilling cycle we want to use. Now, drilling standard would be feed in, rapid out. We can change this to any different sort of ones we wish here. So we've got counter bore and chip breaking, deep drilling, breakthrough, etc, etc. We've got tapping and reaming we can do with this also, and also boring. But I'm going to leave this as it is for now, so that's fine for center drilling. We're just going to spot the center drill with a feed and then rapid away. So we're happy with that. We're going to click on OK. Now it's time to run the simulator to make sure this works. Having a bit quick, so let's zoom in and have a closer look at that. I'm going to slow it down a little bit. In comes our center drill, drills and goes away before the full angle is drilled. So that is absolutely perfect. That's exactly what I wanted. So that's our center drill done. Now we just need to drill the hole afterwards. So to do that, same thing again, the same option, drilling. And this time we're going to change our drill to a 10mm diameter drill because our hole is 10mm. So type drilling and OK. And dimensions, we can add dimensions to this, so I'm going to add 10mm diameter to our drill there. And then we're going to click on all. So what this is doing now, it's selecting all the drills that 10mm for us, so we know which ones we can select. And it's giving us some material recommendations here as well. Well, I'm going to go with the aluminium one. So let's click on this. So coolant is disabled. Well, I want through tool coolant this time. I've got a nice expensive tool here with some coolant holes in the end. So we use through spindle coolant. Speeds and feeds below. Our hole face is asking us to select. Same as center drilling. We just select that there to select our hole. And again, the same as center drilling, we don't need to change any of this. That's for multiple holes. Our heights. This time our height bottom. Our hole bottom. Let's have a look at this. So what's happening here? It's a tool is going to the tip. It's going to break through the end, but it's leaving this angle in here, so it's not going to be deep enough. Now we've got to allow for the angles of the tools to break through, and this is how we do it. We do it the same as we did with the spot drill or the center drill when we're changing the depth. We leave the whole bottom alone here because it's going to the whole bottom. It's just not going deep enough, so we would change this offset so we can visually see that the drill breaks through the cutting edge there and clears the back of the component. So a 4mm offset to our drilling part here on the bottom height would break our drill through the back of the component. So with that in place, our cycle is the same, and we can change this to let's change it to peck drilling. Now we've got two different kinds of peck drilling. We've got chip breaking, which is where the cutter will retract after each peck but not fully retract outside the part. Deep drilling full retract would be a complete retraction after each peck, and this is good to clear swarf. Now since we're using a through tool coolant system, this helps flush all the swarf back out also. So say for example we're having trouble with swarf build up here, maybe breaking your drill. Well, we would use this full retract one here, so the drill would fully retract, all the swarf would be blown away with the coolant coming back out the hole, and then it will go back in and take its next depth peck. Talking of peck and depths, we change all this here. Once we've selected we want to peck cycle, it will give us some options. So peck and depth, I'm going to change this to 10mm. Now we have a minimum peck and depth. After each peck, the peck will shrink slightly until it gets to our minimum depth. So I'm going to make our minimum depth 3mm. So the first peck will be 10, the second one will be smaller, and it'll keep going until it's got a minimum pecking depth of 3mm, and it won't decrease any more than that. And we can add a dwell period. So once it reaches the bottom of the hole, it can dwell for whatever time we tell it to clean up that surface before it retracts back. We would turn that on here, but I'm not going to use that. I think that would be fine, because if we were drilling a blind hole, we would use that to make sure the surface of the blind hole was free from any chatter. Okay, so I'm happy with that. Let's click OK and see what happens when we run that simulator. In comes the tool, it's pecking, it's retracting right outside the material. It's taking a good 10mm cuts each time there. And we're finished. So that's that done. So it's gone through, it's drilled our hole, safely retracted away. So I'll close our simulator, and that's our deep drilling done. So now all we have to do is do our transfer, where we bring our sub-spindle over, grip this, part off, and machine the back face. And we'll do that in the next lesson.